All right, this is where I'd like to actually challenge you to get both these questions correct without a mistake. And this is a course called Quadratic Inequalities. So go ahead and pause the video and see if you can give these a try and try not to make any mistakes. Okay, let's check our work. So for the first problem, let's make sure it's equal to 0. So let us subtract 35. What we'll get is x squared x squared plus 2x minus 35, and let's just say equals 0. Okay, again, this is a greater than sign, so x squared plus 2x is greater than 35, so we're changing it to just an equation here to see if we can find out our boundary points. Let's see if you got these boundary points correct. Let's see. So what multiplies to negative 35? And just factoring here. What multiplies to negative 35 but also adds to 2? All right, so hopefully you should have gotten these two answers here. Multiplies to 35 and adds to 2 would be 7 times 5, and that would be the negative. So it would be x and 7 and negative 5. All right, did you get that right? Hopefully you did. Okay, so next step. What is my next step? All right, let's go ahead. Yes, that's correct. So we have to use the zero product property to find out our boundary points. If we switch the signs, we'll get negative 7 as our first boundary point, and our second boundary point would be positive 5. Okay. On the number line now, let's graph those two boundary points. I'll put 0 at the center here. Negative 7 is around there. 5 is around there. So let's see. Did you put an open circle or did you put a closed circle? Remember, open is going to be for greater than or less than symbols. Closed is going to be if it's including our solutions. So less than or equal to, greater than or equal to. So in this case, yeah, you should have put open circles for our boundary points. Okay, again, that's why this is a tough one. It's a challenge. Get both of these questions correct without a mistake. That is a very small and easy mistake to make. So open circles would be what our boundary points should include. All right, good job if you got that right. So now we need to decide, does our graph or number line, does it open up to the middle in region B? Or does it open up in region A and region C where it goes out? All right, so let's decide which one it is. Is it in the center or not? So you might remember a little trick. If it's greater than, it might have to be towards the outside. But let's confirm that theory. Okay, this is my my theory, my hypothesis. I believe this is true because it's greater than. But let's test that hypothesis. We can do a counterexample. Let's see if 0 works, then we're definitely wrong. So let's try to plug in 0 into our equation. So our inequality or equation, let's call it an inequality, is x squared plus 2x is greater than 35. All right, we want to plug in 0 for x. So what happens if we plug in 0? 0 squared is 0. 0 plus 0. Is that greater than 35? Absolutely not. So 0 is not a solution. In fact, anything here in region B, all of those numbers between negative 7 and positive 5 are simply not going to be solutions. So our final answer, yes, region A and region C will work. It will work. Since region B did not work, those other two regions must work. And let's go ahead and write this as x is less than -7 or x is greater than 5. And that, if you got that right, that is absolutely fantastic. That is going to be the correct answer for problem letter A. Challenge problem letter A. Okay, let's go ahead and try letter B. Letter B. Letter B is x squared minus 10 is less than or equal to 3x. So I'm just going to make a little note there. Less than or equal to. So that means it's going to have to be, right? It's going to have to be not an open circle, but a closed circle on our graph. Okay, step 1. Let's set it equal to 0. X squared minus 3x minus 10 is, well, let's change it to equals because we're just trying to find out our boundary points. All right, let's see if we did factor this correctly. What two numbers multiplied to -10, but also added to -3? So multiplies to -10 and adds to -3. Okay, 10 is very likely, you recognize that 10 is 5 times 2. And what would make that add up to a -3? Right. It would be -5 and +2. So let's factor this. In fact, we're already done here. It's x and x. -5, +2. Good job if you got that right. Our next step is to do what, right? Our next step is to do the zero product property. So did you remember to switch the signs? Right, -5 becomes +5. +2 becomes -2. So on our number line, right, on our number line, we want to make sure that we have these boundary points. So let's include 0. Let's include -2, which is pretty close to 0. And let's include 5, right about there. Okay, so yeah, remember our sign here is less than, but it's also equal to. So we're going to include a closed dot. That means, is 5 a solution, right? Is 5 a solution to this inequality? Yeah, if we plug in 5, we'll get a true statement. Right? 5 squared minus 10 is equal to 15. So that is a true statement. So that means it's got to be a closed dot like that. Okay, now, again, our goal is to decide whether this is going to be opening outside or if it's going to be opening inside. So give me one moment here as I change this to blue. And let's see. Is it opening inside or is it opening outside? Okay, last time it was greater than, and that was outside. This time it's less than. So my theory, and hopefully your theory as well, is that it will be in region B, in region B. Let's test that theory, okay? So x squared minus 10 is less than or equal to 3x. Let's plug in the number 0 to see if it works. 0 here, 0 here. Okay, we have 0 squared minus 10 is less than or equal to 3 times 0. So 0 squared is 0. 0 minus 10 is less than or equal to 0. Okay, really think about this because it's super easy to make mistakes with these negative numbers. We have what? Negative 10 is less than or equal to 0. Negative 10 is less than 0. True. That means we are right. We are correct. The number 0 is a solution, and everything in between these numbers, in fact, are going to be solutions. So we can test our theory if, like, let's think about maybe, is it true that 7 might not work? You can try plugging in 7, but 7 wouldn't work. You can try plugging in negative 10, but negative 10 would not work in this equation. So final answer here is going to be our solutions are less than 5 and also greater than negative 2. Between negative 2 and 5. So if you got both of these questions, if you got both of these questions correct, incredible. Good job. And that is where we're going to stop for today.